everybody. Welcome to another episode of She Builds Tech Skills North America. My name is Tamara Gagliardi. I'm a senior solutions architect supporting healthcare life sciences customers in Southern California. For those that are not familiar with the role of a solutions architect, we help customers address their business needs through technical cloud solutions. We're basically our customers' technical advisors. And I'm also a member of AWS She Builds. Through this episodes, we aim to bring different tools and skill sets for our community to help you develop in your career. And today we have a very special episode where we have a panelist of our SA members, Solution Architect members. We'll be talking about generative AI, about foundation models, and also sharing different use cases and a little about our journey as female in the field. I am co-hosting today's episode along the amazing, the one and only Candice. Candice, I'll pass it over to you to tell us a little more about yourself and introduce our panel.
All right. Hey, everyone. So I am Candice Bohannon. Thanks for the lovely intro, Tamara. I also am a solutions architect here at AWS, and I work in Minnesota, working with enterprise engaged customers. So those are kind of larger customers and doing very similar job to what Tamara does. So kind of helping with understanding technical solutions to your business problems and those sort of things. I am an active member here on AWS She Builds Tech Skills. Done a few of these episodes now, and it's one of my favorite parts of my job. It's kind of one of those extra things that I get to do. And I really love it because I feel like it's a great way to kind of encourage those younger females in the field and kind of get different perspectives about what it's like being a woman in technology. So I really enjoy this episode or this whole show. And I'm mostly excited about this episode because Gen AI is everywhere. It is like the word of the last couple of months, at least. Like it feels like it's a very hot topic. And so we're really excited to have here today with us a couple of our specialists from the solutions architect organizations that are kind of focused in this area. So Mani Khanuja is here with us, as well as Lauren Mullennex. And we're just going to kind of kick this off. And as we kind of get started, if you could each kind of give us an introduction about yourselves, like how did you get interested in technology and what exactly do you do as a specialist solutions architect? Like how is that different from Tamara and I? Mani, would you like to get started?
Yeah, sure. Hi, everyone. I'm Mani Khanuja, Senior AML Specialist Solution Architect. And so I'll start with, you asked 2-3 questions together. So the first one is, how did I even got interested in the AIML domain? So, okay, this one is very close to my heart because I am a self-taught AIML specialist in the job right now. But the meaning that all the machine learning or the artificial intelligence, I literally did online courses on those. So that's how I got started. I started getting interested in this when I was working as a project manager. Very different area than what I'm doing right now. So I was a project manager. There was this big data project that I was managing, and that's where everything got introduced to me, like data science, machine learning, how we can get insights, what we can do with the data. And I got so fascinated. I took an online course from Coursera. It was by Johns Hopkins University. It was a specialization. So I did that. Then I did a couple of more specializations. And that's how, everything rolled out. And finally moved into the AML Specialist Solution Architect job. So that was nice. So that was one. The other one was, what was the other one? I forgot. How did I got interested? And then there was one.
What do you do as a specialist solutions architect?
Yeah.
How is that a little different?
So when I started AWS, I started as a solution architect, and Tamara was my mentor. So I literally
Small world.
Yeah, small world. So it was very daunting in the beginning to be as a solution architect at AWS. That was like a really big thing for me. where I was coming from. I was very new to the country, and being new to the AWS, being a solution architect was very overwhelming at the time. But Tamara made it easier. So thank you so much for that. And then I was very interested in the AIML since the beginning, but never got the opportunity really to go deeper. But when I joined AWS, I got all the support that I needed. We have this technical field community program. I joined that, got amazing mentors, and I think in the end, it's all about getting the right people to mentor you. And I cannot emphasize on the fact that it's okay to have more than one mentor. I think that's ideal to have multiple mentors because everyone has different skills and you are learning from them. So it's pretty amazing. So that's how then I moved into this specialist role. The way it's different is I also help the customers, but I help them with their AIML journey. We go very deep into the technology. And even within the technology, like AIML is such a huge field, right? So within this, picking out what you are really passionate about, like just a general machine learning or the deep learning or distributed training or machine learning operations. So you really have to find the area where you are most comfortable with, where you are most interested in, and then that's what I did. So now I focus and go very deep with the customers, specifically on their machine learning journey. And this year, my focus has totally been on generative AI. So, when I was a solution architect, I was working on really wide range of areas. And being a specialist, now I'm focused on a very deep, uh, some few topics, but going very deep into it. So that's how I like to describe like wide and deep, but you pick up your, things that you're passionate about.
Very cool. Thank you for that. I love to hear those kind of more non-traditional backgrounds, like taking a Coursera course on John Hopkins and, picking up a passion. So very cool. How about you, Lauren? Can you introduce yourself and talk a bit about how you got into tech and your current role?
Yeah, hi everyone. Lauren Mullennex. I'm a senior AI/ML specialist solutions architect at AWS as well. So how I got into tech is kind of a bit by happenstance, actually. So I'll take it, I guess, background, go from there. Just kind of really met somebody who was working in the cloud, and I thought that was such a cool concept back then. I heard this thing called AWS, so it's kind of funny how everything comes full circle now. But after working a few years in the field, and I became a solutions architect at a AWS partner. So then on a project, I heard about something, this AWS AI service called Textract. And it hadn't been released yet, but I never heard about AWS AI services before. I hadn't really known much about AI/ML. I'm self-taught as well. So everything I learned had really just been on the fly, through courses, through mentors, just on the job training. So once I started working more in the space, I did take some courses online, like Monty. I don't think it was Coursera, it might have been some Udemy. Also through my alma mater, University of Colorado, had a course. So I just thought this was just very cool, super interesting. AWS made it really easy to use AI, and I just thought that this is something I wanted to do. So after I left that role and joined AWS as a solutions architect as well, so I worked with enterprise customers. Actually, Tamara interviewed me, so thanks, Tamara, for helping me get here today. I had a mentor, an awesome mentor, who was very deep into AI/ML. So I just thought, wow, this is really cool. Let me learn as much as I can about this. We have a technical field community that I joined pretty much right away. Started getting involved in different projects, just learning from everyone that I could. Especially, the women here are very supportive. So I pretty much just tried to get as many female mentors as possible too, and ended up even working some projects with Monty. So it's a very, small world here, but really just tried to learn from the best and really get as deep as I could into kind of my own niche areas. So I decided really right away that I wanted to work a little bit on ML ops and computer vision. So then really when the time came, the opportunity, became a specialist AI/ML solutions architect. And Monty really did a very good job explaining really what the difference is. But I would say I worked in some very broad areas as well. But I kind of already knew my niche and worked in a lot of different industries. And now today I work with healthcare, life sciences customers. So mostly pharmaceutical customers. So I'm very deep in that space, in that domain. And really building solutions for them and determining how to accelerate the use cases and how to use the power of our AI/ML services to make sure that we can, ensure that and put these solutions into production. So work directly then with our AI/ML services, specifically really anything involving what they need, but try to focus on MLOps still, or really what we're calling large language model ops and generative AI. So that's where I am today.
Yeah, I'm very excited to have both of you and experts in the area. I know that we'll have some time to talk about some of those use cases. Lauren, we're in the same space in healthcare, life sciences, and there's other use cases that we'll be sharing with the audience. But before we jump into those use cases and some of the patterns, maybe, Lauren, if you can share with us, how would you explain what generative AI is for somebody maybe that's new to the field? And we'll prime the conversation with that.
Yeah, so generative AI is really using artificial intelligence systems to create new content using existing content. And so this content could be text, image, videos, and audio. And so what really powers this, though, are what are called foundation models. And so I know that's kind of a odd term to some people, but it was coined by Stanford, so you can thank them. They wrote about it in a paper. But what this is using foundation models are models that are trained on massive amounts of data out there. And so this could be public data, really tons of different data that I mentioned, like text, image, video, etc. And so they're trained on this large amount of data so they can solve these really complex tasks. And then really within the space, we're hearing the rise of large language models, or LLMs. And so these large language models are really a subset of foundation models. So they are used for natural language tasks. So we'll get more into that, but essentially using these text data to really solve, and solve solutions, in the space.
Cool. So can we dive just a little bit more into that? Let's maybe for Mani, let's switch it up a little bit. Can you talk a little bit more about what are these foundation models? How are those different from large language models? Lauren said, subsets. And how are those different from our traditional ML models?
Okay, that's very interesting. So what happens is, if you look at the traditional machine learning models, right? So we have this data, and then we train those models on a specific task. For example, if I have to, and we'll stay in the context of language models, right? So for example, if I have to do text classification, or I have to, let's say, predict something, right? Maybe the prices of a loan based on the housing and all that stuff, right? So what happens is, so they are trained, we train the models on a specific task, we use the labeled data to do that. Now with the foundation models, it's very different. The way it is different is now we have large amount of data, like super large, massive data. And in order to use the data, we always thought that, okay, we have to label this data. But with the foundation models, that's not the case, because with this, there is another term that has been coined, which is called reinforcement learning with human feedback. So what happens is that you have this data, you use an initial language model, and then you train another reward model based on the human feedback. So you rank so there's a human who's basically ranking the output of these large language models and training a reward model, which in turn is used to train this large language model. So that's why it's called reinforcement learning, because we use that concept, but where you have a human in the loop, who's ranking the output and training the reward model, and this reward model is further used to train the initial language model. But if I have to simplify it in a very basic terms, is the way you can think about foundation models is, you have this massive amount of knowledge, which is super compressed. And whenever you ask a question, or you want it to classify something for you, it will just look it up in its knowledge base and then give you the answer, right? So similarly, like when Tamara and I were talking the other day, she mentioned that if she has to explain, she generally takes this example of a grandfather who has this large amount of knowledge gathered over experience. That experience is training, the way the training has been done. And based on your experience, you know that, okay, certain things have worked, certain things doesn't work, right? Similar to the reward model that I was talking about. And then you ask a question, and based on that experience, you get the answer. So those, if you have to simplify it, that would be how you can define foundation models. And they can be used on multiple tasks, not just specific. They're not trained on specific tasks. You can fine tune them for specific tasks, but you can use them for various tasks. Yeah, that would be my simplification.
Yeah, I think that makes sense. So yeah, that makes sense. Could you, now that we kind of have an understanding of generative AI in general and these models that go into creating them, can we talk a bit more about the customer journey? So our job, as solutions architect is to connect this back to business problems and how customers can actually use this. So can you, Mani, start to walk us through what that looks like?
Yeah, for that, let's use a visual, right? So I'll just pop up a slide just to make sure that we can resonate with that. So what happens is when we are talking to our customers, we always have to work backwards from a particular use case. So let's say, for example, we have a use case, a question answering use case, for example, right? So I want the model, a foundation model, to answer certain questions, or let's say answer questions based on some context that I'm providing, right? So this is our use case. So the first thing that comes to everyone's minds is, okay, this might be my own domain. Let's train this model. Let's fine tune it. But you always have to take a step backward, because the first step ideally should be to figure out which foundation model would be a good idea. What kind of data do I have? So we start from the initial step rather than jumping into domain adaptation, which is done by fine tuning. So look at your data, look at what is the investment that you are ready to make, what is the return on investment that you will get out of that, and then use techniques like prompt engineering. Start with that. So you can shortlist some of the foundation models based on the benchmarks. One of the benchmarks that I really like is the Helm by Stanford, Holistic Evaluation of Language Models. That's a good starting point. And then figure out those, list down those foundation models in the beginning. Start with prompt engineering. Now, people get confused with what is prompt engineering. Prompt engineering is nothing but you provide an input to the model in a way that you want to optimize on the output that you're getting, right? So you're guiding the model towards the output that is expected by providing an input. So that's why the input itself is called a prompt. And the way we design a prompt is called prompt engineering or prompt designing. There are multiple terms that have been coined. So you start with that. Make sure your prompt is concise, and it's not too big, it's not too small, it has enough context, so on. So there's a lot of things that goes into that. So it's easy to use. You are not changing any model parameters. You're not customizing your models. You are just customizing your prompts, right? So the expertise needed over there is low. And once you're happy with that, you say, okay, you know what, this is good, but I need more. It does a good job, but I need to do more on top of it. And I really want the model to understand my domain specific stuff. That's where the fine tuning will come. So start with prompt engineering, go to the fine tuning. And then if your customer has a requirement, or if you have a requirement of where you want to monetize and build your own foundation model, that's where pre-training will come into picture, where you have like terabytes or petabytes of data, and then you want to make use of it. You want to train your own model. So that it will be huge, cost-wise, expertise needed, as well as time-wise. So make sure that you are focused on the goal, right? What is my goal? What do I want to achieve? So working backwards from your business use case.
Well, thank you, Mani, for sharing the customer journey. And I think having a visual really helps. And then to illustrate, I know that you went through one of the use cases, and Lauren, earlier on, we're talking how maybe there's other use cases that we can share with the audience to kind of put all the information that we've been sharing together on. What are some use cases that you've seen, either customers or in the industry, that are prevalent lately?
Yeah, I think specifically, there's definitely overlapping use cases across industries, but search summarization is definitely one I see with pharmaceutical customers. And so what that could be, an example would be like summarizing research documents or general health documents there. Or in the case of healthcare, summarizing like clinical notes, like doctor's notes. So that's very helpful. And then the search aspect, being able to search a repository and then group all of that together to really expedite like claims processing, for example. Something else I definitely see that I think is very unique, specifically to pharmaceutical customers, is accelerating like drug discovery. So molecular design. So being able to design these drugs. And what's really important in this realm is it takes many years to get approval for drugs, but also to design them. And so these people who are tasked with this are have years and years of knowledge behind their belt, and it takes a lot of time. So being able to use generative AI and foundation models to actually help accelerate this process and be able to supplement like a structure of a protein and with using these foundation models is very helpful then. And then so for an example, back in 2020, I think we all remember, what happened, and everyone essentially banded together to be able to design, these drugs that could be used, for COVID. So that's the use case I definitely see, in the future of hopefully we won't have that happen again, but in our lifetimes, but to be able to accelerate the molecular design process and the drug discovery process, so we can discover new types of drugs for all different types of diseases. I think that's very important in this space.
Yeah, those are all very interesting use cases, and I know that as solutions architects, we also then, once we identify the use case, we help our customers with either architecture patterns and trying to translate that business or that business need or use case into maybe more of a technical architecture. So Mani, I don't know if you can share with us some of the architectural patterns that you've seen with generative AI.
Yeah, sure. So again, let's use a visual for that.
Okay.
I'm a visual person. I even think visually. So let's do that. So Lauren basically touched based on a lot of use cases like summarization, and she talked about some of the text generation process when she was talking about the protein stuff, the molecular design of the protein. Okay, that is so amazing. And then chatbot, image generation, and question answering. So let's touch base a little bit on some of these use case based on the time we decide how far we can go. But let's see. So, for example, like when you are to generate something from the foundation model, like you can have an input request, and then you ask, the foundation model. Let's say I want to generate or ask. Let's take an example of writing an article, right? So you provide some of the features that you want in that article, and then you ask the foundation model to give you the output. Now, in this case, your prompt or your input is smaller, but your output will be bigger, right? So you have to take those considerations in your mind, like because all these things are token based, and sometimes you will see based on different providers that you are being charged on those tokens. So think about those areas as well, which is often neglected. So that's one thing. So if you have like a simple prompt, you want to do some simple write up, like generating an article or maybe replying to an email. So that is also like text generation, where you give an input, which is okay. This is my email. I want to reply back. It can generate a really good reply, and I have tested this on my own, so I know it works really well. So this is like, when you have a simple prompt and you want to generate some text out of it. Then the text summarization. This is also, when you have smaller files, okay, you have this 2-pager slide, you feed into the model, you ask it to summarize it. Now, this is really good when your files are small, because you will be limited by the context length of the model. Context length is the basically amount of text in a layman language that a foundation model can take in and then process it to give you the output that you are asking. In this case, it's summarization. So it's limited by that context length. So if your files grow bigger, like Lauren was mentioning, clinical summary of the patients, or maybe you have some report, financial report, and you want to summarize it, or maybe you have a book and you want to summarize all the chapters of the book. So you will be limited by the context length of the model. So certainly there are ways using which you can overcome this. One way is to use LangChain, which is an open source framework. So what you can do is conceptually you take this large file and then you break it into smaller chunks. You feed it to the model. Now, in this particular case, as you're moving, you have this large file, your smaller chunks. You feed it to the model and then you say, okay, summarize. So chunk one, we got the summary one. And then you can take the summary one and the next chunk, feed it to the model, and then you get the summary end. So you are doing recursively going through it. This type of chaining is called redefine. Another way is you have all these chunks, you ask the foundation model to give you all the summaries of different chunks, and then you summarize, you basically create a summary of the summaries, right? So that's like more like a map reduce kind of a pattern. So there are different patterns, redefine, map reduce. I've seen really good results. That's why I mentioned it over here. So that's how you can kind of use it for, summarizing large text. So that was about the text summarization. And one way to reduce hallucination, because that's a very common question that has always been asked, is we want the model to be able to give an output which is factual and which is based on the text that we are providing. If I'm asking it to summarize this one pager or multiple pages, then we have to get that summary based on that particular context, right? So one way is that you can provide better prompts. That's what I touched base in the beginning on the prompt engineering section, when I was talking about it. So the better prompt you write, the better output you can get, right? So that's one technique using which you can do. But when we come to question answering, right, that's where these hallucinations become more, started showing up more. So, for example, if I have this question answering and I use this model and I say, okay, you know what? Tell me who was the president of United States in 2020. If the model is trained on the 2020 data set, usually you will say, yeah, it is trained on that. So model will know and it might give you a good answer. But if you might be asking about the current, super current information, it might not be trained on that. So how do I overcome? So there are multiple things. One is, how do I overcome hallucination? How do I know whether my answer provided by the foundation model is good or not? The second is, do I always have to keep training the model on the newest and the latest and the greatest data to get the right answer, right? Because if we are fine tuning all the time, there is a cost associated with that. So how do we overcome? So for that, what you can do is, what you can do is there is another pattern which we'll touch base, which is called retrieval augmented generation. So what you basically do is you want to provide some document, right, which will be your context. And you might want to say, you ask the question and you give instructions to the model that answer based on this context. And then you will see that you might get better results. So, but for the smaller documents, again, this is good. But when the documents go bigger and bigger, this might not work. And what if you have your entire knowledge base, data from different data sources? How would you do that? And that's where there is a concept of retrieval augmented generation. So you create your entire knowledge base, you store the embeddings. Basic embeddings are nothing but a numerical representation of the text. And that's where it maintains the semantic meaning of the text. So rather than saying, okay, I'm matching or doing the search based on the similar sentences or the phrases, it does it based on the embeddings and calculates the distance between them. So that's how you can do semantic search, where you retain the meaning of the text and then feed that along with your new question to the foundation model to get a better and more accurate answer. So something like this, right? So you have this new data, this is your document store, you use the embeddings model to create the embeddings, which is nothing but the numerical representation of the text. You store it in some database like a vector database. And then you basically do the search, find the relevant based on your question. So you have your question, you will look up the knowledge base, and then use this enhanced context and add it as a prompt to your foundation model to get an accurate answer. So this will overcome actually three major challenges. One, I don't need to keep fine tuning it on the new data, right? This has seemed to work really well. Second, it reduces hallucination because now I have better context, and the better the context, the better the output the foundation model will give. So it will reduce hallucination, right? So, and then also the context length. We cannot just feed in the entire knowledge database to the model. So we have literally, by using this architecture, we have literally overcome these three major challenges. So this is, about, and you can then build multiple architectures on top of it. Maybe build a chatbot on top of it. Use this retrieval augmented generation architecture that I'm showing you, and create a way to store your chat history, combine it, and create a contextual based chatbot. Very, again, very relevant, very common use case that I work with all the time with my customers. So yeah, so some of those are my architectural patterns that I wanted to go into this.
Very cool. Always love to see the visuals and the architecture diagrams as well. I guess we're kind of wired that way. Another topic that I think is really interesting, actually. So I also am in the technical field community for AI ML, and my favorite thing is also ML ops. So I care a lot about, how do we retrain a model and how do we deploy a model? That's one of the key things that I think can be tricky. We can play with these models a lot, like we can play with them in our environments, but how do we deploy these models, and what are some of the challenges that we run into? Lauren, do you think you could take that question? How do we deploy models, and what are some of the challenges there?
Yeah, I think in general, there's quite a few challenges with the rise of foundation models and large language models, and we're still really trying to understand within the field what this really means as far as how do you evaluate these models? We'll say, how do you actually ensure that they're meeting your standards? Monty mentioned Helm as one standard that I point to customers to. But what metric do you have to look at? Is it accuracy that works for you? This is a little bit different than traditional or classical ML. Also, you have to take a look at, I'd be remiss without mentioning like bias, for example. Since these models are trained on large amounts of data and they're not all transparent where they get this data, there's definitely a lot of bias there that you have to address and make sure that you understand what data you're putting into your model, what data is being used to actually train these models. So I got a little bit kind of off topic there, and definitely cost as well. So training these models too requires large amounts of compute and memory. And I know there's a lot out there about what these models trained on, how many hours they were actually trained on compute. But you're not training your model on like a MacBook. Most people don't have access to these silicon chips to actually train them. So there is a cost to actually training a model. And then with that, there is a cost to deployment as well. So I think what's great here at AWS is that we offer a lot of options for training and deployment. We have a service called SageMaker, and so that provides the managed infrastructure for you to be able to do training, your own foundation models. You can do some fine tuning as well, and deployment. And so we have many options that we can show you. And I did work on a blog of how to fine tune a very large language model called Falcon, which is a 40 billion parameter model. So that is just topped the open source LLM leaderboard, and how you can actually take this model. And if you wanted to actually fine tune it for your specific task, you would only essentially have to fine tune really, I think it was about 0.29%, really, less than, a percentage point of the parameters of a model to make it specific for your task. So you're not spending all this time on actually having to go through the process of retraining on the entire, data set, because that would take, again, probably millions of hours. Instead, you could do this on, SageMaker and be able to do this in really, I think it was probably 45 minutes or an hour of the time. So we offer a lot of options for deployment and training, and you could definitely visit that space within SageMaker and with the custom chips that we have like Inferentia and Trainium.
Very cool. And we will have, I believe we have the link to your blog in the summary of this YouTube video. So for anyone who's interested in checking that out, it was just published like recently, last week. So hot, fresh off the presses, and pretty interesting read.
And talking about resources, I know as part of being solutions architects, we do create new assets, new resources for our customers. Now, both of you, Lauren and Manny, have resources that you've created. Manny, any that you're wanting to share with us and the audience?
Oh, yeah. One which is very close to my heart, and this is a shameless plug. I wrote a book last year. It got published, I think, in December of last year on applied machine learning and high performance computing on AWS. It's such a long name, it takes me time to even get the full name right. Okay, so it's applied machine learning and high performance computing on AWS. So it was like very timely because we were working on really amazing stuff at the time. I was working on the distributed training these large language models. I was helping customers on how they can pre-train the models. And I was writing this book. And soon after that, like when we finished the book, there was this whole thing about generative AI became so popular. And you will see in this book, we have chapters on distributed training. We have chapters on some industry specific use case. So we are covering HCLS as well. So that was the chapter that I wrote on the protein structure prediction. So that was really nice. It also talks about some DNA bird thing. So that was really amazing on that book. So that's another one thing. And another latest and the greatest, so this was about the book, but now the latest and the greatest is to get an opportunity to work on, on the foundation models, which are provided by SageMaker Jumpstart, as well as Amazon Bedrock. So Amazon Bedrock, just to make sure that you're fully aware, is a fully managed service using which you can access the foundation models. So we are providing you with the options rather than saying, okay, this is the one foundation model that we provide you and that's it. It's not like that. We provide options with Amazon Bedrock. So you have models, we have models from Anthropic, which is a cloud model. Then we have a model from AI21. Then we have text to image, yes, from Stability AI, that's a stable diffusion model. And then we have first party model, which is by Amazon. And there are two models. One is the Amazon Titan text. The other one is Amazon Titan embedding. So remember, going back to the architecture, we needed an embedding model. So you can definitely use Amazon Titan for creating the embeddings, and then Amazon Titan text as a foundation model, for example. And a very important note is we have to think about, when we are using foundation models, about being responsible. And I know Lauren mentioned about it and touch based. So I would like to little bit expand on it because it's super, super important. So Amazon text model is responsible. The reason it is responsible is it will filter out the output. So if you have profane language or toxicity, it will flag those out. Same with the Claude model from Anthropic. The way they trained their model was actually based on a paper that came out, which is Constitutional AI. And it's in the training itself that they incorporated a lot of this stuff. So definitely read out that paper. You can download it. It's publicly available on Constitutional AI. We don't have time to go through that. Otherwise, I would have loved to. So even that model, when you ask any question or ask any question which might have toxicity or is an inappropriate question, it will flag out because they train their model to be harmless and helpful. So that's one thing. The other thing is that you can also, if you are using, let's say, publicly available model, you don't have control on how that model was trained. So my pro tip over there would be to make sure you add some mechanism to filter out the models, to filter out the model output. One way is maybe you can use an open source framework like LangChain, which provides some capabilities, or build your own. But very important to make sure that the output that the model generates is is not a bad output, like not a toxic output, and it's not generating inappropriate content, because that content can be utilized by really like anyone, maybe children. I don't know, like depending upon their use case, right? So very important concept over there.
And then I know, and thank you very much, Manny. You provided so many tips and shared so many great resources. I know, Lauren, you also authored a book. I know that we've been covering generative AI, but also machine learning. Can you share a little bit about your book and what the audience could expect if they read and purchased the book?
Yeah, so my book's called Computer Vision on AWS. I think it released the end of March, so fairly recent. I did include a little bit of a brief introduction of generative AI. I was actually writing it while really the generative AI hype, kind of started last year, and wanted to include a little bit more, but it talks about transformers, and really these large foundation models are not new. They've been around for a very long time. Specifically in the vision space, talk about transformers and what that really means regarding these large foundation models. And then I also focused a lot on how to build solutions with essentially using little code with our AI services. Recognition is one of them, and then our ML service, Amazon SageMaker. So tried to provide a comprehensive example. Well, really not comprehensive fully, because there's tons of solutions you can really build, but some use cases that I see using these services. So you're able to detect objects, but also detect defects like in machinery. And we include some kind of fun examples in there as well. I also wanted to dive deeper into topics that were very close to me, such as MLOps and designing MLOps systems, what really AI governance looks like as a whole. So designing responsible AI systems too. So I think that's still very important, even though we've been talking about generative AI, that these concepts still apply when designing generative AI systems.
Awesome. Thanks, Lauren. And I know we have one other blog that we wanted to share. Candace, you authored a book. We've been talking about image to speech, and we talked about SageMaker. So can you share a little about your blog? And we'll be sharing those links as we go through the conversation.
Absolutely. Yeah, I'm not quite as published as these two ladies yet. I'll catch up maybe. But this was my first blog that was published, and it went out just not too long ago. And it kind of describes a project that my team and I worked on at reInvent for a thing called Builders Fair. And the project is called Describe for Me. And what it does is you can upload an image to an S3 bucket, has a nice serverless architecture behind it, and we use recognition. I took a large language model that I found on Hugging Face, containerized and deployed that, and that model is what provides an image caption, like a really useful, user-friendly image caption. So you can read about the solution itself there in that link that is created, and there's also a link to our website where this thing is deployed, and you can go and play with a little bit of it. So that was a lot of fun to build out. And we started working on that like a year ago. So it was before I knew generative AI was a word. I was using a multimodal model of some sort that took an image and created text. So I feel lucky to have kind of grabbed onto this train and have a blog published. I feel very, very accomplished. So, yeah. So we are getting close to our time running out here, but I do want to kind of close it out with that woman factor, like being a woman in tech, and like what are some of those key tips and tricks that you want to share with the group. And so one of the questions that I like to ask sometimes is, what is something that you wish you knew when you were getting started, whether that is getting started like in your career, in college, in ML, take it however you want to. But just tell us a little tip that you wish that you knew when you got started. Lauren, let's start with you.
I think that, I would probably tell myself and others that you really should be kind of comfortable being uncomfortable and that you can't know everything as well. Maybe that sounds a little bit scary, but I thought, I'd start focusing on something and then I would just become like an expert maybe eventually in 5 years or something, or maybe I'd eventually become an expert down the road after I'd been in the field for a very long time. And that's definitely not the case. And so with that, really my suggestion is find an area that you're really passionate about, and then don't be afraid to ask for help. Find those, mentors, as Mania was mentioning, and people that you admire, and just ask them, how they got started and what their suggestions are. Most people are very open. Feel free to reach out to people on LinkedIn. Feel free to reach out to myself, or those you see in the space who are working in an area that you have interest in, because we all have to start from somewhere. And I think we all probably experience imposter syndrome at least one point in time, especially being here and then working in AI ML and being self-taught. I work with people who are very knowledgeable in the space, who have PhDs, who are professors, who have been doing this for 20, 30 years. And so that could be very intimidating. But don't feel intimidated. Just try to keep pushing ahead. You'll eventually find your area where you can really be a subject matter expert. And there's always somebody that needs that knowledge, and you can maybe learn about it and how to teach that a different way. So there's always definitely room for growth, and room for everyone to have a seat at the table.
Love it. How about you, Mani?
I would cut it short because I think Lauren covered most of it, but I always used to think that I need a PhD degree to become an AI/ML specialist solution architect, due to which I think I started a little later. I would have started sooner. And another quick thing is, so that's something which is false. You don't really need a PhD. I don't have a PhD, and I'm working as an AI/ML specialist solution architect at AWS, and I feel really good about it and accomplished as well. And the second thing is, which I see is very common, lots and lots of people, whether they are females or even males, feel it. I feel it even today, is validation. I think I look for validation a lot, which is which I think is not that good. The reason is we all need validation, some kind of validation in your work, or even in your personal life, right? But you have to trust your gut. You have to trust yourself. So the most important thing is to seek your validation first rather than seeking validation outside. It's more about seeking validation inside, right? So this is important. So if you can, and that's my thing, is try out if you can switch this. I know we all need validation. We need our validation more than we need anyone else's validation. So that would be just my thing. If I knew all these things, even if a year or 2 years ago, I would say that would have been great. So it's never too late to start.
Wow. Thank you very much, Mani and Lauren. I agree with a lot of the tips that you mentioned. Imposter syndrome, I think it's pretty big within our community of solutions architects. And thanks for sharing your tips into how you overcame those imposter syndromes in those scenarios, and also how, from the validation point of view that you mentioned, Mani, I think continuously developing ourselves, taking those courses, those really gives us with the tools that helped us gain a little more trust and power within us to know that we're bringing forward great solutions and skill sets to the community. So with that, I know that we're running out of time, but I did want to take a moment to thank all of you for joining us, the audience, and also Mani and Lauren for joining us from the experts booth over there as AI/ML Senior Solutions Architects. It's been amazing to have you. And Candice, you're always a great co-host and another She Builder. We also have an up-and-coming episode on Tuesday, June 11th. So next week on Tuesday, please RSVP. We're going to be sharing with you our next episode. You can look also at the previous episodes that have been recorded at AWS. She Builds Tech Skills North America. We're sharing the Splash page where you can register for the upcoming episodes. With that, thank you very much, everybody, for joining. It's been a pleasure, and have a great day.
Yep.
Thanks, everybody.
Bye.
Bye.